Hello, I am Michelle Corwin-Edson, and with me, Dr. Michelle Corwin-Edson, and with me is my husband, Dr. Daniel Edson. We're here to help out with the fiber draw tower, trying to get it back up and running after several years being mothballed. So I'm going to kind of just walk down through the tower top to bottom and describe what each of the unit or what each of the pieces are. Yep. So we have right at the very top, you can see there's kind of a gripping mechanism, and that is called the chuck. And it's actually manually opened. I can get up there later and show each piece more in detail, like how each piece works. I just want to give an overview first. So we've got the preformed chuck, which is manually open, and you insert a rod or an actual fiber optic preform into the chuck, and then you tighten it down to hold it firmly. The preform feed unit is actually can move in all three axes, so we can feed it up and down, and it also has an X and a Y motor on there, so you can very accurately position the rod or the preform centered over the center of the tube furnace. So that can move down slowly, it can move down quickly, and it can move up quickly. It's a pretty nice unit. And then the next component down is these two furnaces here. We have on the left, we have a low temperature furnace. We've discovered that the max temperature seems to be 500 Celsius on that one, so I'm not sure what glasses it can actually run, but it's not going to be able to get hot enough for even soda lime silica. So we quickly moved over to the induction furnace, which is on the right, and that's actually called the silica furnace. In the software, that one's called the silica furnace. The one on the left is called the soft glass furnace in the software. So those that one on the right, the silica glass furnace, I think the minimum temperature is probably 800, and the maximum temperature is what do you think? 1200? See? That's it? Okay, well we'll figure that out when we actually get it to operate fully for us. Right now it is turning on. We're just not seeing the temperature readout yet. So those two furnaces, you can see they're kind of on a panel. That panel can actually slide left and right, obviously, so that we can put one directly in center and slide it over and put the other one directly in center there. So it's kind of nice that you can switch between the two. The next piece down, right here, this is the laser mic. Unfortunately, it is not working right now, we've discovered, so we have a call into the company, TechMet. Oh, actually, that's not their name right now, but yeah, they're going to get back to us with some replacements, so we can hopefully get a new laser mic there. And what that does is it actually measures the diameter of the fiber that is pulled through the furnace with a laser, and normally it would read out up here, but I don't know if you can see that. Can you see over? Okay. Normally that would be working, but that whole unit is not giving us any display right now. So, but it's 20 years old, so it's kind of understandable. But that would tell us what the fiber diameter is, and then as we come down through the laser mic, there would be, well, we don't actually have. Oh yeah, that's this guy right here. So there's a polymer coating unit. If you wanted to coat your glass with a polymer to protect it or make it more bendable, that's normally what they do with optical fibers. Normally there's at least 2 layers. I guess this is just a 1-layer unit, but that's 1 layer is better than nothing, I guess. So you would flow probably a UV curing methacrylate. This is the pump and the container for the polymer, and then it pumps through here through the cup. I don't actually know how it holds it just sprays on. Yeah, it must be an atomized spray, which then coats the fiber. Just due to surface tension, it probably coats around the fiber, and then from there the fiber will go through. There's an iris here. You can open it up to get it started, and get your fiber through there. And this is actually a UV lamp curing system. It's Fusion UV. It's actually called a Light Hammer 6, and this will turn on, the UV light will turn on, and it will cure the polymer very rapidly. And then from there, as you have a polymer coated silica fiber coming down, you put it through these two rotating guide eyes here, and then this is the cap stand. It's actually, you can just consider it like a pull wheel, but there's a belt that's tensioned up against the wheel, and then you just put the fiber through there, and this will continually rotate at whatever speed you tell it. And then that fiber will be pulled by the cap stand. And the next thing you do is you bring the fiber up through these two rolling guide eyes here, over this drum, and then down below this wheel here, and this has a weight on it so it can feel if there's a fiber there or not, and if not, it would just fall and kick out the alarm. And then from here, the fiber goes over this wheel, through the guide eyes, and onto the winder. Now the winder will actually, it's rotating like this, but it can actually move back and forth as well. So that's pretty much the whole unit oh yeah, well you can tell more what those do, but top to bottom. So for the silica furnace, it has to, because it's high temperature, it has a graphite induction element. It has to be protected with inert atmosphere and also water cooling so that it doesn't overheat. So we have four flow meters for the argon. I don't know, so we've got a chamber, we've got, where are they? Oh yeah, gas window, upper gas window, the chamber, the heating zone, and the lower gas window, but we don't have gas windows, so I'm not sure what that's about, but oh yeah, okay, gas window. So you want to make sure that there's good flow on all of these. We've had them all between about 1 and 4, with the chamber being the most important of those. So we had that at about 4, right? 4 liters per minute. And then we have up above, we have a manifold for all the water cooling.
Readout lights need to be green.
Yeah, there's flow sensors on each of the lines, and the readout lights, I don't know if you can see, looks like there's 6 lights. It goes from red, yellow to green. You want to make sure you're at least in 1 or 2 or more green lights on each of the sensors so that you're sure that you have flow. If anything,
And you can adjust.
Yeah, you can adjust the flow by the valves, the dial valves there at the bottom. So you want to, if it's not green, you can turn it up or down and make sure that you get all of the sensors showing green. And then if anything is not operating, so we've already discovered that if the flow is not high enough, if one of those valves goes to yellow, it will actually shut down the furnace, and it'll alarm. So if you hear the alarm comes out of here, you can hit the alarm acknowledge button to turn that off. It's kind of loud, but it will then show that the furnace is off over here.
So here we are on the back side of the draw tower. We have a nitrogen tank, which right now is just a regular grade nitrogen tank, and then we also have a regular grade argon tank. For the nitrogen, we are using that to cool and purge the soft glass furnace, and a little bit of the high temperature silica furnace, and the argon tank is only for purging and protecting the graphite from oxidation on the high temperature furnace. We also have back here a pump that doesn't need to do anything, and a pump for drawing the cooling air across the UV coater. It's a very high temperature lamp. It's a high temperature power supply, so it has an interlock where it needs to have the airflow to cool it. And that's what these 2 green pumps are for. Additionally, we have water cooling to both of our furnaces and also to the power supply for the high temperature induction. So the water currently comes in from the city here and it goes to drain. And then if we follow that up, we have two valves. We have this black valve and this yellow valve. The black valve sends water to the low temperature soft glass furnace, and then the yellow valve sends water to the high temperature silica furnace. So you would choose which furnace you're using and send your water supply to that single furnace. And that's all we have back here. We also have a vacuum pump. There's a blue vacuum pump that we are still trying to figure out exactly what we need to do, but this is connected to the high temperature furnace for the purge, with the idea being that we purge the oxygen out of the system before we start refilling it with the argon, again, just to protect the graphite from oxidation. Okay. And then I was also, since we're back here, we might as well look. The yellow box is the transformer for the induction for the high temperature silica furnace. So you can see it has water cooling, which are the blue lines. It also has those really big black lines with all the copper fittings coming out of the box. So the black lines for the induction has water cooling supplied to the furnace through the pipes, as well as the power, the voltage and the amperage necessary to do the induction on the graphite. So those both go through there. So you definitely don't want to touch that part of it as a safety precaution.
And then the Onitech land unit is the
Okay. All right. So if we see this unit next to the big yellow box, there's a little brownish box with a black cable with a yellow tape coming out of it. That's for the infrared pyrometer, which measures the temperature inside of the furnace as a feedback on the high temperature silica furnace. The low temperature soft glass furnace has two different control thermocouples that give the feedback for the temperature control on the low temperature soft glass furnace.
So we are going to start up the control panel and just kind of show the controls and some of the inputs. So to turn it on, you just push the switch up. Some of the normal sounds is doing the normal system checks. Should I pull this off? Okay, you see that okay. So this tells us that it was supplied by NM Knight Company, who actually, I think, was the first company to buy Heathway or work with Heathway. Heathway now is actually out of business and completely defunct. So we called NM Knight to see if we could get some manuals or diagrams of any sort. They did find some stuff for us, so he's going to see if he can Xerox or photocopy some things and send it to us, so at least we have some documentation on this unit. And then the controls, so all of the controls were designed and built by Controls Interface Limited. They are not in business any longer either, so don't have a lot of help if something were to go wrong, but I'm sure another company could figure out if you needed to change anything or change any of the settings. But this is a touch screen, so we just touch to get in here. The first problem we have or issue we have is that if we did want to configure any of the settings, which I don't think we really want to do right now, we try to press the configure button, and then it needs a 4-number PIN, which we do not know. So the NM Knight Company, Jack was going to see if he could find the PIN for us and call and let us know what that was, at least. So maybe we can get that. It would be good to have that as well. So we're just gonna, well, I guess we're just gonna exit out of there. We can, however, get to all the controls without that PIN. So that PIN is just if you want to change things or reprogram it somehow. So we're fine to operate everything without that, which is good. So on the first page here, we have the preform section. We can type in a feed rate of the preform, which was the very top unit that holds the glass rod or preform. So we can touch on there and type in a number in millimeters per minute. I think we've decided that 50 is the 50 is the maximum millimeters per minute. So that's something that whoever's going to be operating this in the future definitely want to play around with that number and see. You're going to have to do a mass balance between the volume of glass going in and the volume of fiber coming out, and balance that feed rate with the pull rate. Just make sure that those numbers equal each other so that you're not running out of glass or feeding too much glass. So the next is the position of that preform when it's running. I think when you start it up, it just zeroes out the position at 0 millimeters. When you start to run it, that number will change. And then load distance. I actually don't know what that means, but I'm sure we can figure that out. And then you've got the preform, and then the capstan was that bottom winder that we showed you. So these are the two rates that you kind of have to match up. So this is in millimeters per minute, and this is in meters per minute, because you're pulling a lot quicker than you're feeding, just because the fiber is so very, very small. So you can input. You can't input draw speed. Oh, it's not running, I guess. But it will all. Yeah, I'll talk about that. It will also track how many meters of fiber is actually pulled as well. So that's pretty nice metrics to have. And then the XY unit is also for the preform. If you can control the XY here, right, left, front, and back, and then you can exactly position the preform centered over the tube furnace, so that it zeroes out when you start it up, but then you can turn it and see those numbers change as well. When you first start it up, you can check all of that, but in order to really get anything to work, you have to press the reset button. And so you can see that error that was up there is now gone. So now with the reset button activated, everything down here is now able to be pressed. So you can feed the preform. I can press the feed button, and it will start feeding at 50 millimeters a minute. And you can see that it'll take some minute to ramp up to that speed. That's pretty fast. And you can see how much the position has changed.
Adjust it.
Hmm?
Go ahead, adjust it. Adjust the speed.
Oh, adjust the speed here, right? So we can put that down to 20. And it'll slow right down to 20. So we can stop that. We can press the fast up button, and you're going to see that position go back to 0, possibly negative. So it goes very fast. And it went negative. So it does know when you start it up to 0, its position out. And then the X and Y, is it out, completely out? Yeah. So I can move it over. Oh wait, so, automatic, manual. Huh?
No, it's easier to do it up there.
Yeah, that's true, we should say that, but I don't know why this isn't working. No. It was working yesterday. You could hear it. You could hear the motors turning. You can hit position reset, which will probably zero that back out, or not. Oh yeah, there it goes. Okay, so that's 0 now again. Don't know why that XY is not. It wasn't running. Furnace. Because I know we did that. Huh? Yeah, there's also a X and Y. There's a panel up there, which I don't know if you can show that carefully. The panel with the big red button up there. Is actually another touch screen where it's better to be up at that elevation so that you can see how well centered it is. If there's XY positioning, and you can feed it down and fast up from up there as well, which is probably much better to do up there rather than down here. I don't know, maybe I pressed something on that, which is why this is now unactivated. But this was working yesterday. I think I just have it confused with the upper panel at the moment. Select a furnace. Oh, okay. So, what?
Just hit left for the furnace, for the first furnace. Hit the select furnace.
Oh, over here. Okay, so yeah. So we have other screens that we can go to. So we can go to the silica furnace screen. Some nice things here. It tells you how many hours the element's been operating. It can tell you if you're going like very high temperature, you need to use a vacuum, what the pressure is, and also how many purge cycles that it's gone through. Right now, it's showing a water flow failure because we don't have the water on at the moment. That would actually show water flow good if we turn the water on. This is the gas. Is that the argon?
Yeah.
Okay, so Dan is turning the water on, and now it says water flow is good. So the gas here, this is the argon that we showed you in the back. Dan is going to turn on the argon tank. And then if you want to see the flow meters actually. Oh, sorry. Oh, right. It's not in position yet, right? We're doing things sort of out of order. But if I turn that on, what will happen? Nothing.
Nothing.
Oh, okay, sorry. So we turned that on. And now you can see good flow rates on the argon. Over here, okay. Yeah, we can adjust the flow rates. Just, right is closed, so the flow goes down. Turning it left is open, so the flow goes up. It's those guys. And we're not using the vacuum pump or the purge, so those are going to stay off. So right now you see that it says no furnace in position. That's because we're between the two furnaces right now. In a minute we'll get up there and you have to physically push the furnace over, and then there's actually two sensors back there, so it knows which furnace is in position. So it'll actually show us on that first screen again whether the silica furnace is lined up or the soft glass furnace is lined up, which is really kind of cool. Then there's a little locking mechanism right in the middle there. It's got that black knob, like hexagon knob there, that will actually pop into the locking position and make sure that they can't be moved during operation as well. So you have to pull that knob out before you can slide the furnace either way, which was really hard to pull when we first got here. Okay, so for the silica furnace, the minimum temperature that it will start to read, the IR pyrometer can't read below 800, so it won't show any temperature readout until it gets to 800 Celsius. We're going to see how high it can go. So for soda lime glass, we're going to try that out as well, but we're thinking a good temperature is probably going to be around 1,000 degrees Celsius. We think you want to be close to log 4 or maybe a little closer to log 3 in viscosity in order to have good pull soft glass to pull the fiber without too much tension. So you don't want to pull too hard, otherwise you could pull the rod right out of the chuck. Hopefully it would break before you got to that point, but that could be pretty dangerous if you have a big rod or preform falling down through things. That could damage things and be quite dangerous for the operators. So if we were to turn this on, you would see these 3 readouts start to show values with the currents. We've had the current up to about 1300 amps already. The voltage is very low. It's only a couple volts. And then the furnace power was up to about 45%. However, we weren't getting, the IR could not see the inside of the furnace. We had I think our little heating element it was out, so we're moving to the other port now, which is kind of where we're at currently, so that we can actually get a temperature feedback. When we moved the IR to the top, it all of a sudden started to read out, and it shut down or decreased all the power at that point. So everything is working. We just need to get the right port assigned to the IR pyrometer. Anything else on this page? Okay, you can select the soft glass furnace if that one is in position. Very similar things here. There's actually two zones on the soft glass. There's an upper zone, an upper coil, which is about 3 inches in length. Then you can see a couple water cooling coils, and then you see a very tight wrap, 3 tight wraps of the main temperature zone, and then there's more water cooling coils beneath that. So it does have 2 zones. If you have a very thick preform, it's kind of nice to have that preheat, because it can kind of soak the glass and get the whole thing a little hotter. So you can potentially pull soft glass very quickly. So if you have the preheat, you can kind of maintain a high rate of pull. So you can set these separately. So you can set the temperatures. There is the target temperatures. You can set that one separately. The max temperature on this that we can enter is 500. So if I enter 501, it's not going to like that. So you heard the sound. So as soon as we back off to 500, it's happy. So this one also, I believe, will take only 500 as well. So it's not recommended to have them at the same temperature, however, because then you can start pulling from the upper zone instead. So you just want to get that close, but not too close. So about 100 degrees separation is probably good to start. This one has a delayed start time, so it's telling you what time it thinks it is. It thinks it's 2:34 right now, but you can click on the time and enter, a time in the future that you want the furnace to turn on. So it's kind of a nice feature if you want to do that. And I think that would be when the auto start. If you enter a time here and hit auto start, then that would kind of be linked up. Or you can choose ramp enable, which is then you come in here, and this is the zone 1. Is that preheat zone? Did we decide? Oh yeah, preheat. Yeah, preheat ramp. I don't know why it doesn't say preheat, but it says zone 1 is the preheat. It's that upper zone. So it's still set at 400. You can, what isn't it saying? You can set the ramp in degrees per minute it has 3 stages, I guess, if you want to use all 3 stages of ramping. I don't know why the low temperature furnace has much more controls than the high temperature for some reason. But yeah, you're talking about ramps. You can ramp up here, and then you can dwell, and then you can ramp up again. That kind of, basic furnace controls. So you have stage 1 ramp to the temperature, and then you can hold it for however many minutes you want. I believe if you just put zeros in the rest, yeah. Right, so you would put that in here. If you just want to ramp up and hold, then you put in some very long time, I guess, for stage 3, right? Well, they need to be the same. So if you run for an hour, 60, put in 60 minutes. This one has another, so that, I don't know why we had that in there. Huh?
Yeah.
If you just put 0 in, it'll take out that next stage. So I think it only has 3 at max. That's the preheat. Then the main temperature is basically the same. Has a couple more stages if you want to get even more fancy. It's a similar idea. Again, ramp to a temperature and then hold for a certain number of time, and then you ramp up to the next temperature and hold. So you would want your two pages to be copacetic. So you want them basically saying similar times. Okay. So go to coding. So this is for the UV lamp. There's no control on the control panel for the polymer. That's controlled by, let me show you this here. So essentially you take this lid off. That's going to take a while, so I won't do that. You take the lid off, you pour your polymer in there, at some viscosity, and then where does it get its air? The nitrogen? Okay, so the nitrogen tank in the back will provide a pressure, so it pressurizes this vessel, which will then send, there's an actual straw in here, so it'll pressurize and then it'll push the liquid out, so then it'll send the liquid to the coating cup, which is just a spray, air nitrogen atomized spray, or pressure spray, I guess. So that's what will coat the fiber. So there's no controls for this on the control panel. It's pretty easy. What? Turn the valve up.
Turn the valve? Turn the valve. Yep, pressure gauge. Turn that up.
Is it on? It's not doing anything. Huh?
Keep on.
I don't know if this is tight. What are you telling me to do? Just down all the way.
Should actually do that.
So you think it's connected to the...
Yeah, there's an actuated. That blue comes out when actuated valve.
Oh, okay. So there's no real controls for it other than just turning it on and off. Apparently it's linked to the UV lamp. When you press the coating on, it will turn on both units at the same time, I guess. Okay. Yeah, and this will not work. It will be kind of yeah, it'll be disabled until you turn the capstan on. I guess it's kind of nice that they're all linked, but also annoying when you're trying to troubleshoot things. Okay, so the coating controls. So this is just the UV curing lamp controls, really. Oh, yeah, well. I don't know how. Okay, so down here is separate power to the UV lamp. Turn that white switch up. And it's good if you don't want any of these to be red. Otherwise, that would be an error of some kind that you'd then have to troubleshoot the error. Then, yeah. So then we have to turn the capstan on in order to get the UV unit to respond. So we would turn this on. Want to turn the blowers on to make sure that you're getting airflow through the UV lamp. It's going to get loud. the lamps to standby. Once you get the blowers on, you tell the lamp to stand by, and it takes a minute to kind of check everything out. Okay, and then it's on, so it automatically turns on. You can see the UV lights on. And you can see that the green light's now on. So it was on standby while it was warming up, and then it turned on automatically when it was ready to go. So back to standby to turn it off. It wasn't on that long, so we can probably turn the blower. So it won't let you. Turned it back on. Back to standby. Lamp is off. Blower's off. Oh. Turned it back on. Still figuring this part out. Huh? Manual. It says off. Turn the capstan off. That turned it off. Okay, so it's linked to the capstan. Okay. Okay, that was a bit confusing. Yeah, we might want to run that one through again. Ah, okay. So there's nothing, oh, now it's, so now that we've turned the blowers off, it's giving us the blower pressure error, so I think it's saying that it wants to keep the blowers running because it's warm. I mean, the lamps were on for quite a bit, and I can feel that they're warm, so it's just kind of saying you should blow more air through, so turn it back on, or it's probably fine, yeah. Okay. But we do have a manual for the light hammer, which talks about all of the errors, the indicator lights, and what you should do in each case. So, okay. So then, the drum winder. That's a lot. We haven't looked, what?
Hold the blue button down a long time on the drum winder.
This one?
Reset. That's the first thing you need to do.
Okay. Well, so, okay. So I did it. So this was flashing a second ago. When you go to start up the drum winder, you have to hold the traverse reset down for a couple seconds to get everything to stop flashing. Then I guess it's kind of ready to go. It's probably just a way to make sure that you're just going to check it and make sure there's nothing on the actual unit, because it will move or knock things off, I would imagine. And this is linked to the capstan also. So the coating and the capstan are linked, and the capstan and the drum winder is also linked. So if I try to start anything, it's disabled again. So I first have to get the capstan going, then I can start the rotation of the drum winder, and you can see that it's now turning. I can also press traverse start, and then it should slowly, you can barely see the unit kind of moving out towards you. Probably can't really tell. But that's how you wind up the fiber and then traverse across that spool, so it's not constantly winding on top of itself. Oh, but this is enabled. Okay. So so we'll start that again. Start the rotation. So you can see that this is blinking, and you can, if you were to press this, Dan is now pushing down on the dancer. And if I were to press it now, it kind of knows that there's a fiber there because he's giving it some weight. But as soon as he lets go, it kicks out. So it stops the rotation of the winder. But it doesn't stop the capstan, so you have to physically push over here, Hannah. You have to push the stop on the capstan for the alarm to stop there.
But ideally, you just grab the fiber.
True, yeah.
Capstan, rethread it, and start up.
Right. But then how do you get the alarm to stop then?
Yeah, we'll figure that out.
Yeah, so you don't want that alarm to keep going if you restart the winder. Okay. So that is, okay, with all this though, these are all the settings for the drum winder. You can, you have to tell it what drum diameter you have chosen to put on there. We have a large selection in the lab, so there's lots of different kinds of drum sizes. So you just need to measure that, or it might even say on the spool what size it is. So input that so it knows what speed it's rotating at. It tells you what the traverse position is. So it did move 3 millimeters, which is why you could barely see that. Don't know what the pitch is, but that's interesting.
How much it built up each layer.
Huh.
Because as the spool gets bigger, it needs to go slower.
Oh, okay. So do you input that, or?
Yeah.
So you have to tell it how fat the buildup is on the spool.
Yeah.
So that's the thickness. Apparently, this is the thickness of the fiber built up on the spool, which affects how quickly you want to turn it, right? Otherwise, you're going to get slack, and it'll just get messy, I guess. So you need to increase that.
Well, you build the first layer, now your second layer is fatter, and it has to go slower to get the same surface velocity.
No, I know. I just explained that, but I'm just saying you have to manually enter it.
Yeah.
It doesn't know. Okay. So it can also track how much fiber length has been collected on the drum. There's also a traverse offset. I'm not sure what that does at the moment. But it also has the fiber break enable here, which is probably the same as this button. These probably work together. And then you can also do traverse auto, so then it would just traverse back and forth, and as it's winding, and collect the fiber up on a nice spool. Okay. So if you wanted to start something up and in the beginning you're not sure that you have good fiber, you can set a start and end millimeters. A band on the spool, so you can start the band and label it as scrap. You can have a test band or a main band. I think, do you have to input these? Yeah. So you could just input these values as you're running through the test to keep track of what you've done instead of having to write everything down. Running, what does that mean? Right, I know, okay. So those are the pages on the control panel. Now what we're gonna do is physically move the silica furnace in place, and we'll show you how to lock that in, and then we'll show how that changes the screen. So let me just go back to This is the first screen. So if we were to go to the silica furnace, it's telling us that there's no furnace in position. So it knows that it's not in the right spot. So we're going to change that now. We'll get the ladder in place. So Dan is going to climb up there and physically push the panel over so the silica furnace is lined up. Then you're going to have to reach around and turn that knob so that it will click in place. There's 2 pins on there that you can just set in the slots, and then once he pushes it in place, that knob falls in and he can no longer slide it back and forth, back and forth. And now you can see that the control panel knows that the silica furnace is in position, which is really nice because it has 2 sensors in the back, so it knows that if it's not reading anything on the right side, the sensor doesn't read anything, it knows that the silica furnace is over in place. So it's a really nice feature. So on the bottom of the silica furnace, we have an iris that you can open or close manually. And that's just a way to keep airflow from pulling up through, like a chimney effect, pulling up through the furnace. So if you're usually feeding something much larger at the top and you're pulling a very fine fiber at the bottom, so it's always good to just kind of close that down a little bit, so you're not causing the furnace to work a lot harder or damage the furnace with air. Closing that down is good. Okay, so Dan is now using the upper control panel to feed the preform down. And any day now, it should come out, keep going. Not quite there yet. Which button were you pressing? Jog down, okay. A little more, you can just barely see the end of it. Oh, okay, interesting. All right, so the preform is now sticking out the bottom. This is probably a good place to start a test, load the preform so that you have a good, couple inches below the hot zone, so that there's weight on the bottom of the rod. When you get to temperature, that weight of the glass will just slowly drop down through, and then you pretty much have to guide everything. Once you break off that large bottom of glass, you'll have a fine fiber. Then you have to just kind of first just guide everything through the coater and the UV cure if you want to use those. Not necessary, but if you do, if you don't want to use the coater, leave it off to the side, but you just still have to feed it through the UV cure. It's just there, so you have to get it through there and then onto the capstan. So the iris on the soft glass furnace is actually on the top. Looks like there's one on the bottom as well. Yeah, there's an iris on the top and bottom. There's probably another iris somewhere, might be lost, that did go on the top as well, because there's actually screws to hold another one on the top. But I think you probably maybe want to leave it off, just because that furnace can get really hot, and you don't want to burn your iris metal. Okay, so he's going to show how to load, if you can see that, I'm not sure, how to load the preform. You manually have to turn the disc with there's a texture on it, on the top disc that can open. You can see him opening the grips and closing the chuck down. The 3 plates hold on to the preform that's in there. So you just want to make sure that's really centered, and tighten it down enough, but if you go too far, you're going to crack. You could crack the rod. But you definitely want to make sure it's fairly tight, because you're going to be pulling on the bottom at some point. Anything else up there? Do you want to show the power connections and what all the connections do, Dan? The black and the clear and the blue.
All right, so this entire unit is the induction furnace. It is a water-cooled shell. The blue lines are water comes in and then water comes out. The water then is hooked up to the flow meters that we had talked about, where we can adjust those and balance them, because we don't want all the water to go to one. We can adjust if one of the lights is all green and one of the lights is only orange, we can turn down this one and open up this one to balance our water based on where it is. Or if we start to feel that there's a little more temperature coming out of one of them or another one, we can adjust it there also. So the water comes in and then it goes back to drain through this set of manifolds. And they're all labeled, right? Coming in and then going out. So that's the blue lines, those are the water. We also have these clear lines, which are the argon, which is attached to that unit. You can see how they come out the top and then go to the clear lines for the protective gases to prevent the oxidation of the graphite. And then as we talked about, the black lines are inlet and outlet of water, and also the power that goes to cause the induction of the furnace. And those are attached to the power supply transformer in the back for the induction. And then up here we also have the optical, this black line is the optical pyrometer fiber optic, IR pyrometer, which is just a fiber optic, so you don't want to bend it too much, otherwise you'll break the fibers. And then that fiber optic carries it back to the sensor that we talked about in the back, which then converts it into a temperature for the control. And we're currently working on moving that sensor from the side to the front. So looking at the soft glass furnace, which is not currently in position, you see we have the two green thermocouples. They're labeled thermocouple 1 and thermocouple 2. So if we have a thermocouple error, those would be the thermocouples you would want to replace. And as we said, those go up into the, you would see where those connect up into the body. Coming down beneath that, we have water cooling for the soft glass furnace, and then we also have an air purge coming from the nitrogen for the soft glass furnace. And similar to other flow meters, we just adjust those to dial in the correct numbers. Again, you want just enough, but not too much, because the nitrogen costs money, and then you don't want to overcool with the water, because then you're fighting your furnace trying to heat as well. So those are those guys. And then we also have a flow meter here for some other air, somewhere, which I believe goes to the coder. So we can have a readout there for how much flow we have going through the coder for supplying the liquid coating before the UV. And then when we just want to shut everything off, we can make sure we turn the gases off to the silica furnace. We turn the purge off. So everything is off. We make sure that we are at a good temperature, right? We can exit out. Just coming to this main screen, all we have to do is turn off the main power. And if we had used the coder, we would want to turn the coder, the UV light off as well to have that power supply off. And when the laser mic is operational, we want to make sure that we turn the laser mic off as well. And then we also have power on this panel. In a similar way, we'd want to turn the power off. Power to off here. And then coming around the back, we'll want to turn our water supply off and make sure that both these waters are off. And then we will turn off the nitrogen at the tank and the argon at the tank. Again, just so that we're not wasting either of the gases, and then the next time when somebody comes in, they don't have to replace the gases. And now everything is turned off and we should be good. And then to take our drum off, which is now filled with fiber, right, we can just unscrew. How do you take this off?
Right now we have the fiber heating up. You can see the orange glow of the silica furnace. And there's a fiber coming down. It's probably very hard to see. You can see it there. It's a very thick fiber right now, so it's having difficulty getting it to stay on the capstan because it just doesn't want to bend. It's too thick to bend around this curvature right now, but we're turning up the temperature. Right now the temperature is at 1250, and it feels like it's going to need a few more degrees here. Getting very close to the capstan though. Hopefully it'll grab it here. There we go. So now we have the capstan actually pulling the fiber. You can see it right there barely. It may break because it's still fairly thick. We're going pretty slow as far as fiber draw speeds are concerned. We have the furnace temperature at 1250. The gas on. Now you can see we have the fiber coming out the other side of the capstan. Oh, and it just broke again. But Dan is setting up the winder. So he's putting a spool on the winder, a secondary spool. And this is a spring-loaded locking mechanism. Yep. Pull the spring back and you can slide it on. And line up the spools so they're nice and straight. And then he's screwing down just to make sure they're nice and tight. Okay, we're going to retract this. We're retracting this rod because we've run out of travel essentially with it, so we need to get a new one put in. It's nice and long. All right, so we're going to remove this rod here, so I'm going to hopefully, yep, I can slide it out. Bring this rod preformed down. It's a little warm. Just grab it up here at the top. There we go. Okay. Hand me the other one. So you can actually feed it from the top, which is what I'm going to do because I don't have enough room really to feed it from the bottom. So I'm going to open the chuck up nice and wide so I don't scrape the glass too much as I'm putting it in. Huh?
Yeah.
The iris? Oh, I'll do that in a minute. Okay, so I'm lowering it down. I want to try to give it as much as... I'll get it in a minute. Okay, so I've loaded the rod, made it nice and tight in the chuck. This rod is a little bent, so I can hear something crinkling inside. Alright, does it have gas flow? Water flow says it's good. It has gas flow, so we're going to turn the furnace back on. You want to ram it right to 1350 or? Okay. So we're make sure that the gas is on and that this says water flow is good before pressing the on button. It is fast. I mean, it cools off fast and it heats up very fast. It's just an odd, odd design. Odd technology design, yeah. So now we just have to wait for the furnace to get back up to temperature and we can try this longer rod. It's much easier to pull right now.
Okay.
49 kind of game time.
What's soda lime?
Oh yeah, it's coming out real fast. I have a feeling that other glass wasn't soda lime.
We do have the algorithm, right?
Yes.
Yes. It is definitely pulling fiber now. We got a lot of fiber all of a sudden. Okay, so Dan is measuring the diameter of this spool. What is it, Dan?
155.
This is a 155 millimeter diameter spool, so we'll input that into the controls after he gets it on. So this spring-loaded tightening device, and then you can tighten it further by hand by spinning it nice and tight on the winder. And he's going to enter the diameter 155. And pitch, what do you want to do for pitch since the pitch we believe is the diameter of the fiber, and as it's wound, you got to do 0.150 or 1. So by putting in 0.150, we were saying that we've got a 150 micron fiber that we're putting on the collet, and as it winds and as it builds up that 150 micron layer, then it changes the speed at which the winder is rotating automatically to maintain a constant speed ratio between the capstan and the winder, that's the capstan.
We also have them.
Okay. Oh yeah. Should go back to the furnace. What else do you want to show?
Measure the diameter.
Measuring the width of the spool or the collet.
Is that 95?
95 millimeters, yep.
We'll try that here. Soon.
Furnace is getting warm.
Yeah.
Well, this is the. No, I don't know how to set the drum. Wait.
Is that this one? No, that's the B. No. Oh, here it comes.
Okay.
All right, we've got.
Get it off.
It's hot. Shit. Okay. Didn't get caught, did it? It's good. Okay, it's pretty warm. Okay, so we have the capstan pulling. Is it feeding?
Yeah, hit feed.
So what kind of ratio did we say?
So 10 meters per minute for 1 millimeter per minute. 10,000.
So we want that at 10?
Yeah.
It's at 15 now.
Okay.
Start there maybe. Still pretty fat fiber though.
Feed this through?
Sure. Okay. I don't break it. So I'm just feeding the fiber through the dancer. Oop, and it doesn't want to bend quite yet. That was a little thick of a section, so we'll give it another. Oh, okay, broke down there.
What up?
Okay, so we have a fiber now that's more flexible because the diameter's a little smaller. Try to see if we can get it fed through the dancers. The dancer. If I can keep keep a hold of it. It doesn't want to see. You can see the natural curvature of it. It doesn't want to really. Well, maybe it will. Got a piece of tape or something? Ah, darn. Yeah, I don't know that it's going to want to be touched this much. Oh, that was a thick section. That won't. It's getting too thick again. What I had manually pulled was thin enough, but this is too thick again to bend. Okay, we're just going to demonstrate starting a fiber on the drum winder, so we weren't able to get a thin enough fiber. It's too fat to want to stay.
Yeah, you're ready to go.